Okay, we're gonna go ahead and go over our probability since I know it's been a while since we've gone over it. So I definitely want to make sure that you guys understand how to do probability and kind of look over some of the problems from your assignment. So I am going to be jumping around to different problems. So make sure that you are paying attention to what problem I'm on. So I'm starting off with question number 5. It says Carmen is playing a beanbag toss game using the game board shown. What is the probability that her beanbag will land on a 10-point space? So I'm going to count how many 10-point spaces there are. So I see 1, 2, 3, and 4. So that means my favorable outcomes are 4 out of, I need to count how many total spaces there are. So I see that there's 1, 2, 3, 4, 1, 2, 3, 4. So this is a 4 by 4. That means that there are 16 total spaces. Okay. But it's a fraction, so I should always, always, always simplify. So I'm going to simplify by 4. And our answer here is 1/4, meaning that there is a 1/4 chance or a 25% chance that she will land on a 10-point space. Next question I'm going over is question 8. Looks similar, but it's asking us a little something different. So it says if Carmen tosses a beanbag 80 times, how many times can she predict she will expect to land on a 25-point space? So I already know that there's 16 total spaces because I just did that one with you. I want to know how many are 25 though. So I'm going to look 1, 2, only 2. There's only two 25-point spaces. So what I'm going to do is I'm going to simplify before I do anything else. And I get 1/8. Now my answer isn't 1/8 because that's just what happens for the probability of one time. I want to find out for 80 more times. Remember, when we think we're making a prediction now, we're trying to look into the future. When we think of the word prediction, we have to think proportion. So I have 1/8 is equivalent to 80 because that's the amount of times I'm trying to predict for. Okay. The 25 just had to do with the spaces, not necessarily my proportion. So now hopefully you see a relationship. Well, I can get from 8 to 80 by multiplying by 10. So I'm going to do 1 times 10, which is 10, meaning that we are predicting that she will land on a space 10 out of a 25 space 10 out of 80 times. Number 9. Mr. Henderson's class spun the spinner shown 240 times. The tables are shown in the table. The results are shown in the table. What is the theoretical probability of the spinner landing on pink? Okay, so remember, this is when we had a whole discussion. We did paper, rock, scissors. We did our notes over this. Theoretical and experimental are two separate things. When I'm looking at theoretical, I'm saying in theory, in a perfect world, this is what's going to happen. Experimental is us actually doing paper, rock, scissors and saying, okay, you actually won this out of this times, right? So we have to make sure you're paying attention to what this is asking. Theoretical, in theory, this person should land on the pink spinner this out of this many times just by looking at the spinner. So we actually don't need, for number 9, we don't need their experimental. Their experimental is this chart. The theoretical, in theory, is I'm going to count how many pink spaces, which is 2 out of total spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's not my answer yet because I have to simplify. So that's 1/6. So in theory, they would land on it 1 out of 6 times. Okay. Every 6 times they spin, they would land on it 1 time. Now, is that what actually happened? You would have to look at their theoretical probability, and we would look, and it says that it would be 83 out of 240 times they landed on pink. So again, or 39, I'm sorry, it would be 39 that they landed on pink. So, right, that's the actual experimental, but I don't want experimental, I wanted theoretical. What I just said might give you a hint to the other problems that are going to ask about the same situation, but in theory, again, in experimental. So experimental is we're looking at the actual process that they did, the experiment, the actual times and amount of times that they did it. Again, theoretical is in a perfect world. Number 14, this is the last one I'm doing. It says Nevea spins the spinner once and then picks a number from the table. I want to find the probability of blue and a multiple of 4. So I'm going to look, this is a compound probability, but it's independent from each other because it's a spinner and a board. So they're two separate things. I'm not taking something out, I'm putting something back in or not putting it back in. Two separate events are happening. So I'm going to look for how many blue. So it's 2 out of 8 sections. Remember, we find compound probability by multiplying. Multiples of 4, I'm going to look 4, 8, 12, 16, and 20. So that's 5 out of 20. Okay. Now, we could do the multiplication, but I want to simplify to make my life easier. So we're going to simplify the first one by 2 to get 1 over 4 times simplify by 5 to get 1 over 4. We multiply straight across, so our answer is 1 out of 16. So again, you can watch this video again to kind of help you out maybe with that theoretical or an experimental or especially like compound probability. This assignment is for a grade, so make sure that we're working and showing work for every single problem. If not, then we might have to redo it.